Hello. Hello, everyone. We still have pizza, so if at any point you want more, feel free to come up while I'm presenting. Today, I'm going to be talking about bash scripting. So you might be wondering, why should we care about bash scripting? And the reason is, a lot of the times in security, you're going to end up doing the same thing over and over and over again. And so you can be like that cat on the right and tap on your keyboard all day long. But that's not really practical because it may work on one machine, but what if you have to manage 3 machines or 5 or 50? It becomes a problem when you try to scale it. So it's a lot nicer when we take those things that we do repetitively over and over again and wrap it in a script. That way, instead of wasting our time typing out simple commands, we can just sit there and chillax and focus our attention on the big brain stuff. So that's what today is about. And here I included links to all the slides, so it's easy to navigate afterwards for reference. First things first, I want this to be interactive. If you're eating pizza, that's fine. If you want to practice writing the script yourself, there's a bunch of different options. Either you have Linux, so you can just do it on your machine. You have a Linux VM, so you do that. Or you go to pwn.college. Pwn.college is an awesome website that teaches you a lot of binary exploitation, but also how to use Linux. And the cool thing is, if you have an account, which is free to make, you can just spin up a terminal whenever you want. So right here, I just do start. And then it takes a bit of time to load, but now I have a terminal and I can run commands in here. So I'll be doing this for the presentation to like go over how to actually do things. And I'm going to zoom in so it's easy for you guys to see. But enough of that. Yeah, here it is. Let's move on. So before we talk about actually scripting, I'm going to teach you 2 tools that are very useful. One is Tmux and the other is Vim. So Tmux is a terminal management system, which basically what that means is that instead of having one terminal, you can have multiple terminals. So let me go ahead and do Tmux in here. And so you'll see it changes the output a bit. So now I have this thing down here. And let me move this so I can yap while typing. Hello? Okay. Oh. So this is Tmux. And we can do a lot of things here. Like, for example, we have a bunch of different commands that we can do to navigate this. So right now we have one terminal, but I want to make multiple. So I can split a single window into multiple what we call panes or panels. So I'm going to do Control B and then either double quotes to split it sideways. So Control B, double quotes. So now it splits it like that. And so I have 2 different sessions I can do like that. But if I want to split it horizontally, I do Control B and then the ants, not Control B and then the percent sign, and it splits it like that. So now I can navigate between these by doing Control B and then arrow keys. And each one of these, I can run a command. For example, like that, or I can do that. Oh. And basically allows me to do multiple things at once. But we don't just have panes, we also have windows. So if I want to start fresh and make a new window, I do Control B, C, and that's a new window for me to play with. And I can do stuff here, whatever I want. And maybe you keep on doing this and you make many and many windows and it becomes hard to manage. It would be nice if we could rename them. So you do Control B, comma, and then you can give it whatever name you want. So the idea of Tmux is it makes things useful because you can see multiple things at once. And to navigate between windows, you just do Control B and then the number of the window. And so it lets me alternate between all of these. So that is that. And let's go back. All of those commands are here. You can also scroll in Tmux, but it's kind of confusing. You need to do this, and then you can scroll up and down. And if you want to get out of scrolling, press escape. And if you ever want to leave, just do exit, and it kicks you out. There's a lot more available, but you won't use them most of the time. I include a cheat sheet here with all the commands if you want to have fun. But that's Tmux. Any questions there? Okay. Next up is, oh, and here's an example of me in a TMUX session doing a bunch of stuff. Next is Vim. So Vim is a text editor. There are a lot of different text editors you can use. For example, Nano is usually the beginner-friendly one. Emacs is the sort of antique one that the big brain people use. But Vim is kind of like the standard text editor. I feel like eventually in your path, you'll end up using Vim. So why not learn it now? Okay. It's kind of confusing at first, but it allows you to do a lot of things. So Vim operates in modes. You have your standard mode, which lets you run commands and do fancy stuff. And then insert mode, which allows you to do text like you would in Notepad. So let me go ahead and demonstrate Vim here. Let me go to a new window. So Control B2. And let me do Vim test.txt. Okay. So here, this is what it looks like. Right now, I can type stuff, but it's not really going to do anything. It's not typing to the terminal, you see? So I need to press I if I want to start inserting. And you see at the bottom, it says insert mode down here. Now I can type stuff and do cool things. There's different ways, like there's other commands you can use. So insert just I inserts in place. A inserts by moving, like it shifts one. And then O lets you do a new line. So there's a lot of like little neat things there, but the main thing is you want to go into insert mode when you want to type stuff, and to leave, you press escape. This is standard mode when you're not inserting stuff. And in standard mode, there's a lot of things you can do. There's three main things that I want to teach you guys about. One is searching, two is editing, and three is macros. So first up is searching. How can we find something in a text file? For example, let's say I want to look for the word cool. So I'm going to do a slash and start typing my word. And you can see it highlights when it's looking for something. Like that. But let me do a different example, actually. So let me vim Etsy password, because that has a lot of data we can look at. And wow, we see a lot of stuff. What if I want to see everyone that has, let's do bin false. Actually, bin bash. So I'm going to search for bin bash. And does anything come up? There's one, root can do bin bash. If I want to find the next instant, I can do a lowercase n. And, oh, it's just search in bin. So it's searching every time bin shows up. And I can press n over and over again to keep going. Or I can do capital N to go backwards. So that's how you search in Vim. Any questions there? Okay, cool. This is pretty useful, honestly. But it's not very cool or fancy. So let's think about something else. I'm going to go ahead and make another text file. Typing with one hand is difficult. So let's say I want to edit something. So I'm just going to go ahead and put a bunch of random data. Oh, hello. Okay. Here I have some song lyrics. And let's say I want to replace wherever it says goes with a different word. So what I would do is whenever I want to run a command in Vim, I start with a colon. So you see colon. And then I want to replace the string. So I'm going to do %s. Now the syntax here gets a bit wonky. So let me look at the slides to show you what it looks like. It looks like this. %s, the thing we're looking for, the thing we want to replace it with, and then this G flag, which means apply it everywhere. Because sometimes you might have the same thing show up multiple times on a line. By default, it'll only replace the first instance of it on that line. So G says make it global, do it everywhere. And so let's see what it does over here when we try to do that. So it would be, I want to replace the string goes, and you see it automatically highlights with does, and then do G, and boom, replaces everything. So much easier than just manually editing it like that. So that's pretty cool. And then the last thing is macros. So when I'm editing in Vim, I'm pressing a bunch of keys. We have all these keystrokes. What if I want to do the same thing over and over again? Wouldn't it be nice if I could copy what I'm doing and then replay it over and over again? So for example, let's say that I want to go to the end of the line and add a new word, like bye-bye. So how can I do that? Well, first I'm going to start recording. To record a macro, you press the letter Q and then the name of your macro, where the name is just a single letter character. And the reason for this is because maybe there's multiple patterns you want to save. What if there's multiple things you want to do over and over again? That way you can have multiple macros. So let's go ahead and do one macro. So I'm going to press Q. And note it says Q down there. And then I press A. And it says right there, I'm recording macro A. So now whatever I do is going to be saved. So what I'm going to do is I'm going to go to the end of the line by doing a $. And then I'm going to append. So it brings me, now I'm in insert mode. And I'm going to add the word bye-bye. And then I'm going to escape to get out of it. Go back to the start using the caret symbol and go down to the next line. And then I'm going to stop my macro there by pressing Q. Line goes away. It's done. We're saved. So how do we get this back again? Well, they gave us a hint. You have this @ sign here. And then you do the name of your macro. So watch this. It was A. Boom. It happened. And I can do it again. Boom. But what if I had like a billion lines and pressing 2 characters is too time consuming? What if I could just hold 1 character all the time? If you do @ sign, it repeats your last command. So if you want to do the same thing over and over again, you could just hold @ sign forever and just go and do everything. You can type a number also? When? Like before, after that? So like 1 at? Oh, like this? Wait, so I can do... It's not working. That's fair. 3 at... Awesome. That's really cool. Thanks for teaching me that. I didn't know. So that's pretty cool. There's a lot more to Vim, and it is confusing to learn it all, but there's cheat sheets available, so you can learn neat tricks like that if you wanted to. I'm just sharing with you the ones that I've used most often. So any questions so far in Vim? Nope. Chill. And then the last thing is exiting. So let's say I want to save what I wrote in a file. There's 2 things I can do. One, I want to save my changes. So I'm going to do colon and then WQ to write to the file and quit. So it's going to save my changes and exit. And so if I want to edit that file again, you see the changes persist. But let's say that I do something like I remove a word. Yeah. And I don't want to save those changes. I do Q exclamation mark, which forces it to not save any of the changes and just forces the quit. Now when I look at it, oh, you see none of my changes saved. So there's just a bunch of neat tricks like that. You can also delete lines using DD, and you can later paste those lines by pressing P. You can do lots of stuff. You'll learn more and more. But the main cool things is searching, replacing, and macros, because that really speeds up how quickly you can do stuff. So any questions so far on Tmux or Vim? Nope? Yippee! Okay. Then we can stop with the background stuff and start talking about actually scripting. Oh, also, there's a vimrc, which is a config file. Because when you use Vim, you may notice that for specific languages, for example, this is, if you had a Python script, it's going to highlight the syntax so it looks more readable. how does Vim know how to highlight stuff? How does it know to make comments colored blue? It's this vimrc file. And so there's this special syntax here where we can define a file type based on the name of the file, and then certain keywords we can match on. So a keyword is like specifically. So sneak, anytime sneak shows up, that's going to be referenced by exact name. And later I can set exact name to be a certain color like purple. So now anytime sneak shows up in a txt file, it's going to be colored purple. This is the general syntax you can follow. Like there's other things you can do, but this makes it easy to work with. You probably won't do this, but if you want to do super fancy and make your terminal like rainbow colors, you can do that if you want to. But it's not really important. Shell scripting is what's really important, so let's talk about that. First of all, shell doesn't refer to one thing. There's a bunch of different shells. Shell just refers to whatever language we're using in the terminal. The OG one is SH. And in my opinion, SH is the best because it is the first one. So you know how there are so many different distros. Like there's Linux isn't a distro. There's Debian, Ubuntu, Fedora, Red Hat. Then you have weird ones like BSD, Solaris, and they may have different versions. Basically, in a competition environment, you don't know what you're going to get. So it'd be nice if the thing we made works for everything. Since SH is the OG, it does work on everything. It's small, it's fast, and it's compatible. So you can run it on any machine without any dependencies. However, because it's old, it's also super clunky and doesn't have cool things, which I'll mention later. But there are also other shells because people realized that SH kind of sucks and they wanted to make it better. So afterwards, they made CSH, which is like, man, I love the C language. What if I made shell like the C language? So that's what that is. No one uses it nowadays. Your company still uses CSH? What? That's crazy. Okay, so some people still use it nowadays. There's KSH, which stands for the guy who made it. His name is like Korn or something, but it's basically CSH, but fast. A lot of these are very similar. Dash, so there's another one called Ash, which is named after the guy who made it. And the purpose of Ash is to be minimal and POSIX compliant, so it works on all sorts of different distros. However, it doesn't come by default on every machine like SH does, which is why I don't recommend using Ash. It shows up pretty rarely. And Dash is just the specific Debian/Ubuntu version. Then there's Bash. That's the one that you all know, the one that's popular. Everyone loves it because it has things like arrays, which SH does not support, like I'll tell you later. And then finally, there's two newer ones, like released in the 2000s, ZSH, which is the Z shell, and it's supposed to be super customizable. And it's supposed to be like the modern Bash. You see it sometimes. I don't know how often it's used, but it does show up. And then finally, it's Fish, which is supposed to be like friendly shell. I've never really used it. I don't know how friendly it is. I just think the name is funny. But for any sort of shell, because we have all these different types existing in our terminal, when we run a program, how does it know which one to use? At the start of your script, you're going to include this line, the shebang. It's a hash and an exclamation point, which we call a bane. So it's the shebang. And you would just use shebang bin sh or shebang bin bash, whatever you want your language to be. So that's going to be the first line in every single one of our scripts. So let's talk about a bit about sh and why I recommend using it. The pros are that it's lightweight, it's portable, basically allowing us to run it on any machine without any dependencies. Because in a competition environment where very first thing you need is as soon as you get on that machine, you need to run these scripts. You don't want to waste time installing dependencies or be like, oh, it's not supported. Oh, well, guess we're just going to cry. Those are what's good about sh. Something unique about it is it's different from most programming languages you're familiar with in the sense that it's centered around file systems, something I call file-oriented programming. Basically, you do not have arrays. You do not have classes. You have essentially nothing but variables and functions. So how do you store stuff? Well, you can store it as a variable, but sometimes that's not really ideal. So instead, you store it as a file and you do a lot of file manipulations. So you need to kind of change how you think. And instead of doing everything in the program, you throw everything into a file. And that's kind of how bash scripting works, in my opinion. The problems, you can't really do a lot because it is the OG version, it's limited. If you want to include any sort of extra commands, you're going to have to waste time installing those commands. And at that point, why don't you just use Python or C? Another thing is if you wanted to be super POSIX compliant, that restricts your amount of commands even more. And like I mentioned earlier, no arrays, no classes, so it's kind of clunky to work with. But it's what we got, and it's really good at what it does. So let's dive into it. First up is variables. For a variable, you just do the variable name equals its value. No spaces in between, because if you put spaces, Bash is going to cry at you. And for this value, I'm not sure about it if it cries on all versions, but on some distros, it does not like having spaces in between the values. For the value, it could either be a thing on its own. For example, if I wanted the number 3, I could just put 3 there. But if it's something like a sentence, there's going to be spaces in the middle. I don't want it to break in the middle. So usually we put the variable name in quotes. That's just the safest way of going about things because we know it's going to include everything. Additionally, you can also actually include dynamic variables where the output of a command gets stored as your variable. And so how you do that is you do this $sign and then your command in parentheses. And so what that's going to do is when it sees that, it runs the command and it stores the output as a variable. So now you can reference this later. Ways this may be important is, for example, I want to do who am I so that I can do something specific for my user. Or I could do something specific to the distro. So I could run like uname to get the distro information and then do my command based off of that. Yeah, so that's how it works. And then how do you reference the variable later on? Again, you use the $sign. So there's going to be $sign and then variable name. These brackets aren't necessary, but they help separate it. Because what if I want something immediately after with no spaces in between? Shell on its own isn't going to be able to tell where the break is. So you put these parentheses here to help it understand, yeah, we break that word there, and this is what I want, just this variable. And again, you should put it in quotes if your variable has spaces. That way it doesn't break midway. Everyone good on that? Okay, cool. Then move on to functions. So functions in SH are pretty simple. It's just the function name and the stuff it does. You don't really worry about arguments when you define it, because there are no arguments, as far as I know. Instead, you just reference an argument using $sign symbols. So let's go ahead and let's code an example. Let's just make a simple program that outputs whatever you give it, okay? So again, that first line should be the shebang. And then here, I'm just going to print the first argument I give it. And see, how do we get that argument? You just put it after the function name like that, and it just calls it like that. But we can do this also within the file as part of a function. So we can go ahead and make a function here. And you see like there, the function just took the argument. So to go over this, function name and the argument. And so what does this function do? It just outputs the name with silly prepended to it. And so here, this $1 refers to the argument that I passed when I called the function there, as you can see there. And if you wanted to do more arguments, then that would be $2, $3, so on and so forth. Any questions with that? Yeah, Sammy? So that's a good question. From practice, I know you can go up to 12. I assume it goes up to 256, but I don't know. And I don't know why you would be using that many arguments. There probably isn't. It's an argmaps. There's a local variable. That's cool. Wait, would it be in like my bash RC? Okay, okay. So apparently it's a variable you define somewhere. So if you want to be silly, you can set it to 1,000,000 and have really long functions. Any other questions? No? Awesome. Okay, let's move on to the next step, the next building block. So we talked about functions and variables. So now we can already do a lot. But let's talk about printing. Because before I was shown echo, but actually I'm going to recommend not to use echo. Echo is simple, echo is easy, echo is not good. Printf is good. And the reason is that echo changed over time. Sometimes you have flags that are supported on earlier versions, like the TAC-E flag to do stuff like regex, that aren't supported in later versions. So sometimes when you use an echo, you'll think, oh yeah, my thing's going to work. And it works on your current version, but you're given some really old machine and it breaks. And you're like, what? So that's why I prefer to use printf. And printf, so echo on its own is nice because it automatically adds a new line to the end. So for example, like that. Printf on its own does not. So instead, what you need to do is you need to add new line characters manually, which, I mean, it's something, but it's not that hard to do. And it gives us more control over it, so we can make our output look exactly as we want, and we know it's always going to look that way. But this is kind of boring. My terminal is bland. It's only one color. I like colors. Let's make more colors. So there's this thing called ANSI escape characters. Not ASCII, ANSI. And so what this does is it allows us to have colors in our terminal. There's a bunch of different ways to include these escape characters. The one that I found works best on all machines is you do this thing, the 033 bracket, and then your number, and terminate with M, where this number specifies what color do you want. It could be a color. So for example, we have 41 is red here, 42 is green, and so on. But it could also be a modifier. For example, you could have bold, or you could have hidden or italics. Some machines even support flash in text, where it goes like pa, pa, pa. So that's fun, but it's not supported on everything. So this is how you can make your text pop out. And if you want to add multiple features together, for example, what if I want bolded red with a blue background? Well, I would just take the number for each one and string them together with these semicolons. So red is 41, so I would do, or actually red is 31. So I'd do 31 semicolon bold is 1. So 31 semicolon 1 semicolon whatever 44. Okay, and so we can actually try this in here with printf. So let me go ahead and type that out. So 31 for red text, 1 for bold, and I think 44 for blue. And remember, terminated with that M, and it just does the rest. However, I don't want this to be there all the time, so I'm going to reset my colors afterwards with 0. Okay, and let's see what this looks like. Woo! It's colorful. So you can do all sorts of fun stuff with this. You can even make videos if you really want to. Like someone made a Rickroll using this. Um, you can do lots of stuff. Any questions on that? Nope. Yeah, so the main reason I like printf is because you can always have fun colors like that. Okay, let's go on to actual programming stuff. There's so like I said earlier, there's no arrays and there's no classes or structs or anything like that. But we still have if-else statements, so that's nice. It looks sort of like this: if uh, if a condition, then execute this stuff here. If you want to leave it blank, you can just do a colon there, like I have here. But if you want to execute commands, you would put it there. Bash does not care about spacing. So you can do two spaces, you can do 3 spaces, 4 spaces, no spaces, uneven amount, whatever you want. Just do something that's readable, okay? What it really cares about are these keywords. So you'll notice I have 2 different things here. 1, I have a command, and 2, I have this Boolean expression. If you want to evaluate an expression, you do it in square brackets like this, where it's a single square bracket separated by 1 space on both sides. And so this would just check if this variable is equal to true. But you can actually do something else. You could have a command. And so if the command executes successfully, it counts it as true. And if it fails, it counts it as false. The reason this is important is because later I'm going to talk about a command called grep, where if it finds a string, so grep basically searches files for certain strings. If it finds it, it returns true. If it doesn't, it returns false. So if you want to do conditional statements based on whether a file has a certain word, that's nice. But if instead you wanted to do something based on, let's say, whether a file exists or whether a variable is a certain thing, then you can do it like this with the square brackets. But you can't do fancy stuff like ands or ors unless you want to use bash, but that's not supported on all systems. In SH, you can do and also? I hope so. Okay, we can test that. String comparison? It's a Boolean statement. They don't exist? Okay, I'm sorry. I'm wrong. You know everything. We also have for and while loops. For loops, I don't really use much, but the idea is like for this variable in this list of possibilities, I can do things using that variable, where you would just list the things there. I know there's other things you can do, but I don't really use them that often. And not all of it is supported in SH. So for loops, I just don't use that much. Another thing is a while loop, where you can have, again, a condition or a command here. And it's going to be this do done, where the commands you want to execute are sandwiched between the do and the done. These things you can use, have fun with them. I personally haven't used them that much. Any questions so far? Nope. Okay, cool. Let's continue going. Ooh, piping. Okay, piping is an interesting thing. So whenever we have a program, you're used to having standard in, standard out, and standard error. And shell has that too. As soon as you start your shell, it creates 3 file descriptors. One of them is to read, so 0 is stdin, and then it makes 2 writes, one to stt out and the other to standard error. So you can actually reference these inside bash, where 0 means stdin, 1 is standard out, and 2 is standard error. And so you can actually pipe output to do different things. For example, something that you see often is, what if I don't want error messages to be displayed when I run a command? So if I'm running a command and I don't want error messages, so like command, I'm surprised that works. What? Okay, yeah, command not found. That's an error message. What if I don't want the error message? Well, then I can just pipe my errors, so that's file descriptor 2, and I can pipe it to dev null, basically a file that doesn't do anything. And you see there's no more error messages. Or I could pipe that to standard in if I wanted to, but I wouldn't do that because that's crazy. Or I could pipe it to standard out like that. So I'm doing a lot of things here that may not make much sense. So let's go over it in more detail. There's two different ways, three different ways you can pipe. One is pipe in between commands, where you use this pipe symbol. And what it does is it takes the output of this command and automatically pipes it to this command. The other thing you can do is pipe to a file. So output of your command gets saved to a file. And if the file already exists, it'll override it. If you just want to append, then you do the double greater than sign. And so this is how you can pipe between things. One reason this is useful is if later on we'll talk about searching through files or searching for specific keywords. Sometimes you want to parse the file and then search for something. So we'll get to that later. But for now, this is what you can do. You'll say show up. And like I said, you can also do it for the file descriptors, which you may sometimes use. Any questions? Am I going too fast? No? Okay, cool. Now, this is the best part. There's three commands that are really important when you're doing bash scripting: grep, awk, and sed. And the reason is because shell scripting is all about files. We want commands to be able to interface with those files. Grep is great because it lets us search for things in files. Awk allows us to parse files or to parse output so we can extract specific keywords. And sed allows us to edit files. Technically, that's not entirely true. Each one of these are in their own a full-blown programming language that can do anything you want. However, it is confusing to do, so you really only use it for the simple stuff that I'm about to show you. But if you want to go crazy, you can make programs entirely out of just awk if you really want to. So let's go ahead and look at how these are used. So for grep, we wrote grep for the pattern in the file name. And what it does is it outputs any lines where that pattern is found. So for example, in etc password, if I want to look for wherever root is in etc password, I can run this, and boom, we get the two lines that root shows up on. Which is nice, because if we're looking for something specific in a file, and the file is very large, this lets us do things easily, get what we want. There's a few different flags that we can do. For example, what if I wanted to get every line that was not root? I could do grep tac v. And so that displays everything that doesn't have root in it. It's like an anti-grep. Or if I want to search for multiple things, like root or hacker, well, then I can do tac e and have each of these things here. And so boom, it has both of those displayed. And the other thing is grep, you can use as a condition in your if statements. If this file has a keyword, do this, else do something else. And so what I could do is I could make a statement. So what do we have? Simple, right? I could do like if grep root in etc password, then I'm going to just print one thing. Oh, right. If then. And so you see it tells us root is present. However, we have other junk in here. We have these lines that grep showed up with. What if we don't want that because it clutters our output? Then we can make grep quiet with tac q. And then boom, it just shows us that. So grep is useful when we want to search a file. Next is awk. So awk syntax looks weird at first, but it's the same thing over and over again, so you get used to it. It's awk, this thin print, and then you print out the things you want from the file. So what awk is going to do is it's going to parse the files and separate lines into specific fields or specific variables. For example, let's look at Etsy password. And we'll see that Etsy password is very big and very confusing. We have the user at the start, this thing, blah, 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 blah. Lots of different things. What if we want to isolate a specific field? Well, I can do awk to do that. So I'll do awk, printf, print, and then what field do I want to isolate? Let's say I want to isolate the user and the UID. So field 1 and field 3. So field 1, and then I'm going to separate with a space, field 3. And then I end it, Etsy password. Now, by default, awk is going to assume that you're a delimiter. So the character we're going to use to separate a line into fields, by default, it's going to assume that it's white space. However, we don't always have white space. In this case, it's a colon. It's not white space. So that's what the tacf parameter is for, to separate things into different fields. And so what we do by running this command is we get every single user and their UID. So this is useful if, let's say, we want to create a script that basically iterates through all users in a system and sets their user ID to 0, so they're basically root. We could do that using awk because we can list all the different users like that. But in order to actually do it, we would need one final piece, which is being able to edit our file. And that is where sed comes into handy. So sed is like the Vim stuff we were using earlier to replace strings. It's basically the same command. It's going to be s, find, replace, and then g, file name. So let's say, let's go ahead and look at test, because that's fairly small. Let's say I want to change everything that says bye-bye to hello. So I can do that. So I'll do sed. And then let's go ahead and do s, bye-bye, hello, g. And then my file name here. Boom. And we'll see it did it. It's changed everything where it said bye-bye to hello. So this allows us to modify files. However, if we look at our file, the cat, we'll see that it's the same thing as before. It didn't change. And why is that? It's because sed by default doesn't edit the file. It modifies it and prints the new version to your terminal, which is what you saw there. If you want to actually modify the file itself, then you do the tac-I flag to modify it. And we're not going to get an output because instead the file is modified. So if we were to print out our file, boom, you see it's changed. And so with the power of those three, grep, awk, and sed, you can find strings and files, you can separate lines, and then you can modify them. We can also chain these together. So for example, let's get every line that has root on it and see what their last field is. So like we have this, but what if I wanted just that last field, which is 1, 2, 3, 4, 5, 6, the 7th field, right? Let's say that I wanted to store that as a variable. So I want to isolate it. So what I can do is I can utilize the piping that we talked about. So I can grep and then awk to separate it. And I want to print that 7th field. What's wrong? Typo. And boom, we've isolated that 7th field. And this becomes useful because we can keep on chaining it as much as we want. And it can get more and more complex depending on how deep you want to go. So that concludes the lecture. I'm surprised I finished in time. Yippee. Uh, you guys have learned a lot. I'm sorry if that was a bit dry, but it's interactive. You guys can make your own scripts now. You can do whatever you want. If you ever have questions, you need help, feel free to reach out to me. But you now have the skills to make crazy things. So have fun. Do we still have pizza? There's one pizza slice for me. Okay, thank you all for coming. Have a good night.